Hello everyone. For this tutorial video, I'd like to talk about the fundamental theorem of calculus in terms of line integrals instead of normal integrals, as well as give a proof of why the formula is the way it is. We first start at the line integral of a gradient function and the dot product of the tangent vector with it. This simplifies to, once we express it in terms of a parameter t, the integral from a to b of the dot product of these with respect to change in t. And we know how to compute the dot product as the sum of all the components of the two vectors. So we do that and we get the change with respect to parameter t of the function of vector r of t integrated with respect to t. We next remember that the integral of a derivative is simply the original function from calculus 1, and if we have a definite integral or an integral between two specific points, then it would be a difference of the indefinite integrals at these 2 points. So we use the same exact logic and come up with a conclusion for the formula of a line integral in its most simplest form. So now we can see one problem that applies this formula is evaluate this line integral, and we are told that c is any path that starts at these two given points. So we compute the vectors at the 2 points as simply the components of the points given, and then take the difference of the functions of these vectors. We remember we were given what the function was in the problem, so we plug this in, and we get a finite answer of 4. Because of how we derived this fundamental theorem of calculus rule, we did not need the gradient vector, and nor did we need any particular path. We simply need to know the beginning and ending, similar to how it works with definite integrals in calculus 1. Now that we have seen how the fundamental theorem of calculus works for line integrals, we can talk more thoroughly about what conservative vector fields are. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.